Hello, geometry students. Today we're going to talk about rectangles. They are a special type of parallelogram. So first let's see where the rectangle falls in the flowcharts. Quadrilaterals are all four-sided shapes, and parallelogram is a four-sided shape where both pair of opposite sides are parallel. And then under the umbrella of parallelogram, we have three special cases. In today's video, we'll be talking about the rectangle. Before we go on though, I want to first remind you of all the properties of parallelogram because a rectangle is a parallelogram, so all the properties of a parallelogram are true of a rectangle as well. So for a rectangle, both pair of opposite sides are parallel because it's a parallelogram. For a rectangle, both pair of opposite sides are congruent because a rectangle is a parallelogram. For a rectangle, both pair of opposite angles are congruent because a rectangle is a parallelogram. For a rectangle, all the pairs of consecutive angles are supplementary because a rectangle is a parallelogram. And finally, if we have a rectangle, we know both of the diagonals will bisect each other because a rectangle is a parallelogram. So everything true of parallelograms is true of the rectangle. But then we've got some special extra snaz on top of all that if it's a rectangle. So we've got the definition of a rectangle, a special parallelogram with four right angles, and the rectangle has one handy-dandy theorem all its own, which states that if it's a rectangle, the diagonals will be congruent. Notice, if the parallelogram is a rectangle, then the diagonals are congruent. So if we see it's a parallelogram with four right angles, then we know, in this case, AC is congruent to BD. Notice it's because these angles are blunt that makes the diagonals congruent. Normally, if it was just a run-of-the-mill parallelogram, it would be slanted to one side and one diagonal would be longer than the other, but not with a rectangle. That's the special thing about the rectangle. Now, we have to think about this logically. If we have a rectangle and therefore we know the diagonals are congruent, like the theorem states, we also have to remember that because it's a parallelogram, the diagonals bisect each other. And so these two things happening with a rectangle, if they start out the same, because it's a rectangle, and they bisect each other, cut each other in half because it's a parallelogram, then their halves are going to be the same. And that's a very special feature of the rectangle. And look at what that implies. That implies that when you have a rectangle, the diagonals chop each other into congruent parts, and so four little isosceles triangles are formed. And then we have to remember that if we have isosceles triangles, the base angles are the same, they're congruent. And so here at each corner, we see these two angles are complementary because of the definition of a rectangle, which says this corner angle, ADC, is a right angle. But we see that the diagonal breaks it into two little parts, and they are complementary. And then we see in the isosceles triangle that the base angles are congruent. Isosceles triangle, base angles congruent, only in the rectangle. So pause and find X and then find the lengths of both diagonals and then press play for the solution. If we know it's a rectangle, then we know the diagonals are congruent, so we can set the expressions equal to each other and solve for X. Once we have X, we can plug it in to get the length of the diagonal. Pause and solve for X and then press play for the solution. If it is a rectangle, then we know the diagonals are congruent, and we also know that it's a special parallelogram, so the diagonals will bisect each other, which means their halves will be congruent. So these four chunks are all the same, which means these two chunks are the same. So I can set them equal and solve for X, and then I can plug it in to get half the diagonal. Don't forget to double it if you want the whole length of the diagonal. So pause, find X, and then press play for the solution. Since we're given a rectangle, we know that the definition of a rectangle is it's a parallelogram with four right angles. And so therefore we know these two angles must be complementary by the angle addition postulate. And so we add them up. They add up to 90. We set up our equation, solve for x, and then plug it in to get our angle measurements. Pause. Find all the angles pictured in this diagram and then press play for the solution. You're given SBR is 30. We know that these two angles are complementary. We know that the rectangle's diagonals are congruent and it's a parallelogram, so the diagonals bisect each other. If the diagonals start out congruent, their halves are also congruent. That means 4 little isosceles triangles are formed with base angles congruent and complementary angles at each corner. Pause, solve for x, and then press play for the solution. If we're given a rectangle, then we know the diagonals are congruent. And so we can set those two expressions equal to each other and solve for x, and then plug it in to get our length. Pause, find all the angles in the diagram, and then press play for the solution. We know the rectangle's diagonals are congruent. It's a parallelogram, so they get bisected. And if they start out the same and get cut in half, their halves are the same. So little isosceles triangles have been formed with the base angles congruent. Also, complementary angles at each corner. That is it for the rectangle. And so I will leave you with these lovely flowers, these lovely bellflowers, and wish you a great day.